We see fire so often that we rarely stop to ask what it actually is, even though the question itself is strange. Fire is not a solid, not a liquid, and not something you can hold, yet it can light a room, melt metal, and completely rearrange matter. That alone should make us pause. Wood can sit in open air for years, surrounded by oxygen every second of every day, and nothing happens. Then, with a tiny spark, everything suddenly changes. Light appears, heat pours out, and the same atoms that were quiet a moment ago begin behaving violently. The real mystery is not why fire continues once it starts, but why it does not start all the time. Most explanations rush into chemical names and formulas, but those often hide the real story. If you forget the textbooks and look at nature directly, you find that fire is not a thing at all, but a process, a consequence of how atoms move, collide, and exchange energy. Somewhere between stillness and flame, there is a simple rule that decides whether nothing happens or everything changes. That rule is written at the atomic level, where nothing is alive, nothing is thinking, and nothing is trying to do anything. To understand fire honestly, we have to follow that rule all the way down, because once we do, fire stops being mysterious and starts becoming inevitable. At the deepest level, nothing in nature is trying to do anything. Atoms have no intentions, no awareness, and no goals. Yet all of the complexity we see comes entirely from how they behave when they are close to one another. When two atoms approach, they do not gently meet and decide what to do next. Instead, they experience forces that depend only on distance. If they are far apart, nothing much happens. As they come closer, they may feel attraction, pulling them together. But if they get too close, a strong repulsion pushes them apart. These competing effects create a very specific situation. There is a preferred distance where atoms can stay together comfortably, and reaching that distance releases energy. You can imagine it like a small ball rolling on a landscape of hills and valleys. There is a deep valley where the ball would like to settle, but before it can reach that valley, it must climb over a hill. If the ball is moving slowly, it simply rolls up part way and then falls back again. Only if it has enough speed can it cross the hill and drop into the valley. Atoms behave in exactly this way, except the motion is invisible and the landscape is made of energy, not dirt. Carbon and oxygen, for example, have a particularly deep valley when they come together, which means a great deal of energy is released if they manage to reach that state. But most of the time, they cannot. At ordinary temperatures, atoms are jiggling, but not fast enough. Oxygen molecules collide with carbon constantly, bounce off and separate again, because they lack the energy needed to climb that invisible hill. That is why nothing dramatic happens when wood sits quietly in air. The system is full of possibilities, but none of them are allowed yet. Heat changes the situation in a very simple way. Heating does not add a new substance or a new force. It merely makes atoms move faster. When atoms move faster, a few of them occasionally gain enough energy to cross the hill. Once even a small number succeed, something remarkable happens. When they fall into the energy valley and bind together, the excess energy has to go somewhere. It does not disappear. It shakes nearby atoms, making them move faster as well. Those atoms now have a better chance of crossing their own hills. In this way, one successful event increases the likelihood of the next. There is no planning, no coordination, and no intelligence involved, yet a chain reaction begins. Each step makes the next step easier. This is the essential mechanism behind fire. What looks like chaos and destruction is really a perfectly orderly process, driven entirely by energy flow and atomic motion, following simple rules that cannot be broken. Once this chain reaction begins, it reveals something deeply counterintuitive about the world around us, because what we call fire is not a special kind of matter, but a self-sustaining pattern of energy transfer. When a few carbon and oxygen atoms finally manage to cross that invisible energy hill and bind together, the energy released does not politely stay where it was created. It spreads outward, shaking neighboring atoms and molecules, increasing their motion, and pushing the system further from calm. This is why fire grows instead of fading. Each successful reaction increases the likelihood of more reactions nearby. The heat is not a byproduct in the ordinary sense. It is the very mechanism that allows the process to continue. Without it, everything would stop immediately. With it, the system feeds on itself. This is also why fire has a threshold. Below a certain temperature, nothing happens at all. Above that threshold, everything changes. This explains why a spark is enough. The spark does not contain much energy compared to the fire that follows, but it does not need to. It only needs to push a small number of atoms over the hill. Once that happens, the released energy takes over, and the process becomes automatic. Now consider what this means for the strange fact we mentioned earlier. Wood can sit in oxygen for years without burning. The air is full of oxygen, and the wood is full of carbon, yet the system remains perfectly stable. This stability is not because the reaction is weak, but because it is too strong. The energy hill is high. Ordinary thermal motion is not enough to cross it. Nature, in this case, is locked behind its own rules. Nothing happens, not because nothing could happen, but because the conditions are not right. This idea appears everywhere in physics. Systems are often full of stored potential, waiting for a pathway to release it. Fire is simply one of the most dramatic examples. As the fire continues, something else becomes noticeable. Light is produced. This light is not decoration, and it is not incidental. It is energy leaving the system in a visible form. Some of the energy released by the forming bonds goes into shaking atoms, which we feel as heat, while some of it escapes as electromagnetic radiation. The color of the flame tells us about the details of that process, about which atoms are involved and how they are moving. But none of that changes the basic story. Energy is flowing from a concentrated form into a more spread out form, because that is what energy naturally does when it is allowed to move. Now, if we stop here, the explanation still feels incomplete. We know how fire works once it begins, but we have not yet asked the most important question of all. Why is there energy stored in wood in the first place? Why does carbon have so much energy waiting to be released when it combines with oxygen? To answer that, we have to step even further back, beyond the fireplace, beyond the match, and beyond the human use of fire altogether. We have to ask where the wood itself came from. Most people instinctively say that trees come from the ground. After all, that is where they grow. But if you think carefully about it, this cannot be the whole story. The ground does not disappear as trees grow. The mass of a large tree is enormous compared to the small amount of minerals it draws from the soil. The real source of the material has to be somewhere else. The surprising answer is that most of the substance of a tree comes from the air. Trees take in carbon dioxide from the atmosphere. Carbon dioxide is a tightly bound molecule with carbon and oxygen already sitting in that deep energy valley we talked about earlier. Pulling them apart is not easy. It requires energy, and yet plants do it all the time, quietly, without flames, without explosions, and without drama. This is where sunlight enters the story. Sunlight delivers energy from the sun to the earth in a steady stream. When that energy strikes the molecules inside a leaf, it can knock oxygen away from carbon. The plant does not create energy. It merely uses incoming sunlight to rearrange atoms into a higher energy configuration. The oxygen is released back into the air as a byproduct, and the carbon is kept, combined with water and other elements, to form the solid structure of the plant. In other words, the tree is built by storing energy. The energy that once held carbon and oxygen together is replaced by energy coming from the sun. That energy becomes locked into chemical bonds, waiting. Nothing mysterious is happening here. No force is being violated. Energy is simply being transferred from one place to another, from sunlight into matter. This means that when you look at a piece of wood, you are not just looking at carbon atoms arranged in a particular way. You are looking at energy that was once part of sunlight, trapped in a stable configuration. Burning wood is not the creation of something new. It is the release of something old. When the wood burns, carbon reunites with oxygen, falling back into that deep energy valley. The stored energy is released as heat and light, and the system returns to a lower energy state. Fire, then, is not destruction in the usual sense. It is a return to carbon dioxide, a return to spread out energy, a return to equilibrium. And when you follow the process carefully, step by step, From atomic motion to chemical bonds to sunlight and back again, the flame in front of you stops being a mysterious object and becomes a visible trace of a much larger cycle, one that begins at the surface of the sun and ends momentarily in a flickering glow before your eyes. Once you see fire this way, it becomes impossible to think of it as something isolated or special, because it is only one moment in a much larger process that is always taking place around us. The key idea is that energy is never created during burning, it is merely released. The energy was already there, patiently stored in the structure of matter itself. The tree did not invent that energy, and the wood did not manufacture it. The sun provided it. Long before the fire ever existed, sunlight arrives at Earth in the form of electromagnetic waves, spreading outward from a very hot source into much colder surroundings. When that light reaches a leaf, most of it simply passes by or turns into gentle warmth, but a small fraction is captured in a very precise way. Certain molecules inside the plant are arranged so that they can intercept that light and use its energy to rearrange atoms against their natural tendency. Carbon and oxygen, which strongly prefer to stay together, are forced apart. This separation does not violate any laws. It merely requires payment, and the currency is sunlight. The plant pays that price continuously, hour after hour, day after day, quietly accumulating energy in chemical form. The result is not fire, but structure. Wood, fibers, sugars, and complex molecules are all energy that has been organized and stored. Now consider what happens when that organized energy is suddenly given a path to escape. A spark does not supply the energy of the fire, it supplies the permission, it opens a channel. Once the channel exists, energy flows through it as naturally as water flows downhill. The reason the process looks violent is not because it is disorderly, but because the difference between the stored energy and the surrounding environment is so large. Energy concentrated in chemical bonds is being released into air that is comparatively cold and spread out. The faster that release happens, the more intense the fire appears. This also explains why fire produces both heat and light. Heat is energy shared randomly among countless atoms, increasing their motion. Light is energy escaping more directly, carried away by electromagnetic waves. Both are simply ways for energy to leave the system and move toward equilibrium. Nothing about this is unique to fire. The same logic applies to every process in nature where energy moves from a concentrated form to a more distributed one. Fire just happens to do it in a way our senses can easily detect. Now step back even further and notice something subtle. The oxygen released by plants during photosynthesis does not immediately rush back to combine with carbon. It accumulates in the atmosphere. This is not because oxygen is gentle or passive, but because the same energy barrier still exists. Even though oxygen and carbon strongly prefer to be together, they cannot reunite without help. That help comes from heat. In this sense, Earth's atmosphere is full of delayed reactions, waiting for the right conditions. Life itself depends on this delay. If oxygen and carbon combined freely at room temperature, forests would burn without warning, and complex structures would never last. The stability of our world is not due to weakness, but to restraint built into the laws of physics. Energy barriers slow things down. They make time possible. They allow systems to exist in states that are not yet finished. Fire is what happens when one of those barriers is temporarily overcome, and a system is allowed to complete a process that has been waiting for millions of years. Seen this way, a flame is not a beginning, but an ending. It is the closing of a loop that started when sunlight left the surface of the sun, traveled through space, struck the earth, and was captured by living matter. The flame is that journey running in reverse. The light you see is not new light, it is old light, released again in a different form. This perspective also changes how we think about heat itself. Heat is not a substance stored inside objects, nor is it something that flows like a liquid. Heat is a description of motion, a way of talking about how violently atoms are jiggling. When a fire heats the air, it is not injecting something into the air, it is transferring motion. Faster moving atoms collide with slower ones, sharing energy until motion spreads out. Eventually everything cools, not because energy vanishes, but because it becomes too evenly distributed to notice. This relentless spreading is the true direction of natural processes. Fire simply makes it visible, and once you understand that, the familiar image of flames dancing upward begins to look very different. You are not watching destruction. You are watching energy complete a journey it has been on since the moment it was created in, the heart of a star. The fire will go out, the heat will fade, the light will disappear, but the energy will not be gone. It will be scattered, diluted, and hidden in countless tiny motions, continuing its quiet work long after the flame itself is forgotten. When you follow this idea all the way through, something interesting happens to the way you think about cause and effect. We often imagine fire as the cause of heat and light, but in a deeper sense, it is the other way around. Heat is what allows fire to exist in the first place. Without enough atomic motion, nothing can cross the energy barrier, nothing can snap together, and nothing can release energy. Fire is not an initiator, it is a consequence. This is why it cannot start itself. It must be invited. A match, a spark, or friction does not provide the energy of the flame, only the initial push that lets the system escape its frozen state. Once that happens, the rules take over and everything follows automatically. This way of thinking reveals how misleading everyday language can be. We say that fire spreads, as if it were a thing moving through space, but in reality, what spreads is a condition. Regions of matter are brought into the right state for energy to flow, and once that state exists, the process continues on its own. The flame front is simply the boundary between where reactions are allowed and where they are not yet possible. Even extinction follows the same logic. Fire goes out not because it is defeated, but because it runs out of pathways. When fuel is gone, or oxygen is limited, or heat is lost too quickly, atoms no longer have the energy required to keep crossing the barrier. The system settles back into stillness. Nothing dramatic has changed. The same laws are operating before, during, and after the flame. Only the conditions have shifted. And once you see that, fire stops feeling like an exception in nature and starts feeling like a perfectly ordinary outcome, waiting patiently for the moment when the rules finally allow it to appear. One of the most persistent misunderstandings about trees is the idea that they are built from the ground upward, as if the soil itself were slowly turning into wood. The roots certainly reach into the earth, but they do not gather the substance of the tree in any meaningful quantity. The soil does not vanish as a forest grows, and the mass of minerals absorbed from the ground is tiny compared to the mass of the tree itself. If you were to weigh a mature tree and then weigh the soil beneath it, you would find that almost all of the tree's substance came from somewhere else. That somewhere else is the air. Trees pull carbon dioxide out of the atmosphere molecule by molecule. The carbon becomes part of the solid structure of the tree, while the oxygen is released back into the air. Water contributes hydrogen and oxygen as well, but even that water ultimately comes from the atmosphere before it ever touches the ground. In this sense, trees are not built from earth. They are condensed out of the sky. This realization feels strange at first because air seems weightless and empty, but it is neither. It is full of matter, moving constantly, colliding invisibly, carrying carbon that once drifted freely through the atmosphere. Over time, sunlight-powered processes gather that carbon and lock it into solid form. What looks like growth is really accumulation. What looks like stability is really stored change. When you burn wood, you are not destroying something that came from the ground. You are releasing something that was patiently assembled from the air, held together by energy borrowed from the sun, waiting quietly for the moment when the conditions would allow it to return. There is another detail in this story that is easy to miss but essential to understanding why our world looks the way it does. When plants use sunlight to separate carbon from oxygen, the oxygen is not treated as something valuable. It is simply released. Over long periods of time, this constant release has filled Earth's atmosphere with oxygen. That oxygen is not calm or harmless. It is highly reactive, always ready to reunite with carbon and release energy, and yet it does nothing most of the time. The reason is the same energy barrier that has appeared again and again throughout this story. Oxygen is surrounded by opportunities, but it cannot act on them without help. This delayed reactivity is not a flaw in nature. It is the reason complex structures can exist at all. If oxygen reacted freely at ordinary temperatures, forests would ignite spontaneously and life would never have time to organize itself. Instead, the laws of physics enforce patience. Energy barriers slow reactions down, stretching processes over time scales long enough for stability, memory, and evolution to emerge. Fire is what happens when that patience is briefly suspended. A spark, friction, or compression supplies just enough energy to allow the system to move forward. Once it does, the accumulated oxygen in the atmosphere becomes an active participant in the release of stored solar energy. This also explains why fire needs oxygen and why it suffocates when oxygen is removed. The flame is not alive, but it depends on a specific chemical pathway to remain open. When that pathway closes, the process ends immediately. Nothing dramatic needs to happen. The same atoms remain, the same forces apply, but the conditions no longer allow energy to flow in that particular way. Seen from this perspective, Earth's oxygen-rich atmosphere is not merely the background of life and fire. It is a long-term consequence of sunlight acting on matter, setting the stage for both slow growth and sudden release. When all of these pieces are placed together, fire stops looking like an isolated event and starts to look like a reversal. The same sunlight that once arrived gently at the surface of a leaf, spreading energy across molecules, now leaves violently from a flame, concentrating energy into heat and light. In the plant, energy was used to push atoms apart, holding them in an unstable arrangement that could last for years. In fire, that arrangement collapses. Carbon and oxygen fall back together, releasing exactly the energy that once kept them separated. Nothing is wasted and nothing is created. The process simply runs backward. This is why calling fire destructive misses the point. Fire does not destroy energy or matter, it reorganizes them. The carbon dioxide produced by a flame is the same carbon dioxide that once fed the tree. The light and heat released are the same sunlight that once powered growth. Fire is not the opposite of life. It is the closing of a loop that life began. And once that loop is visible, the flame becomes a kind of message, reminding us that every structure around us, no matter how solid it seems, is temporarily borrowing energy from a much larger cosmic flow. If you stay with this line of thinking a little longer, you begin to notice that fire is not really about flames at all, but about time. Energy can move quickly or slowly, and the laws of physics decide which it will be. When sunlight arrives from the sun, it travels across space at the maximum speed allowed by nature. When it reaches Earth and is captured by a plant, that same energy is slowed down enormously, locked into chemical bonds that can last for decades or even centuries. A tree standing quietly in a forest is sunlight that has been forced to wait. Fire is what happens when that waiting ends abruptly. The energy that was once released gently, molecule by molecule during growth, is now released rapidly, all at once, because the conditions finally allow it. This difference in speed is what creates drama. Slow energy flow looks like stability. Fast energy flow looks like violence. But they are not different in kind, only in rate. This idea extends far beyond fire. It applies to batteries, to metabolism, to explosions, and even to stars. Everywhere you look, nature is moving energy from places where it is concentrated to places where it is spread out, sometimes patiently, sometimes catastrophically. Fire just happens to sit at a scale we can see, feel, and fear. That is why it has captured human attention for so long. Long before we understood atoms or energy, we learned to control fire, not knowing that we were controlling a shortcut in a vast cosmic process. When humans learned to use fire, they did not invent a new force. They learned how to open and close a gate that already existed. That gate leads from stored sunlight to immediate heat and light. Every campfire, every engine, every power plant that burns fuel is built around that same gate. Modern civilization runs on it. Even when we use electricity or nuclear energy, the same underlying principle remains. Energy is released when systems move toward more stable arrangements. The details change, but the logic does not. Fire is simply the most ancient and visually honest example. And once you recognize that, the phrase frozen sunlight stops sounding poetic and starts sounding precise. The light was not frozen in temperature, but in time. It was delayed. The flame is the moment that delay ends. Eventually, all of that energy disperses. The heat spreads into the air, into the ground, into space. The light races away at the speed of light and is gone forever. What remains is carbon dioxide, water, and ash, all in lower energy states than before. The system has relaxed. Nothing more can happen until new energy arrives. And that new energy will arrive the same way it always has, from the sun, pouring down relentlessly, whether anyone is there to notice it or not. This perspective has a quiet consequence. It reminds us that nothing we build is permanent. Every structure, every object, every fuel source is part of a temporary arrangement held together by borrowed energy. Fire simply makes that borrowing visible. It shows us how energy enters the world, how it waits, and how it eventually leaves. And if you find this way of looking at fire surprising, or if it changes how you think about something as familiar as a burning flame, I'd genuinely like to know what part stood out to you most, so feel free to share your thoughts in the comments. And if you enjoy explanations that strip away the mystery without taking away the wonder, consider subscribing, because this way of thinking applies not just to fire, but to almost everything in the universe once you start following the energy.